This is SpaceTime, Series 27, Episode 40, for broadcast on the 1st of April 2024. Coming up on SpaceTime, the discovery of strong magnetic fields at the edge of the Milky Way's supermassive black hole. New studies show how blue supergiants can be formed through the merger of smaller stars, and peering into the tendrils of a distant galaxy. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new image from the Event Horizon telescopes uncovered strong organized magnetic fields that are spinning around the edge of Sagittarius A star, the supermassive black hole at the center of our Milky Way galaxy. The new observations, reported in the astrophysical journal Letters, are seen in polarized light for the first time. The data shows that these magnetic fields, in the monster lurking in the heart of the Milky Way galaxy, are strikingly similar in structure to those found in the supermassive black hole at the center of the galaxy M87. And that suggests that strong magnetic fields may be common to all black holes. History was made in 2022 when astronomers unveiled the first ever direct image of the supermassive black hole Sagittarius A star at the heart of the Milky Way galaxy. Until then, we knew it existed, but we never actually saw it. Sagittarius A star has a mass roughly 4.3 million times that of our Sun. It's located 27,000 light-years away, and it's the pivot point around which our entire galaxy, including the Sun and Solar System, revolves. Yet despite its huge size, Sagittarius A star is still more than 1,000 times smaller and less massive than the supermassive black hole in M87, which was the first ever supermassive black hole imaged directly. The new observations show that, with the exception of the size difference, the two look remarkably similar. And that made scientists wonder whether the two shared other common traits beyond their simple appearance. To find out, the authors decided to study Sagittarius A star using polarized light. Now, previous studies of light around M87's supermassive black hole revealed that the magnetic fields around it allowed the black hole to launch powerful jets of material back into space. Depending on the angle you're viewing them, they're called quasars, blazars, or active galactic nuclei. Now, building on this work, the new images suggest that the same may be true for Sagittarius A star. One of the study's lead authors, Sarah Izoan from the Harvard-Smithsonian Center for Astrophysics, says that as well as Sagittarius A star having a strikingly similar polarization structure to that seen in the much larger and more powerful M87, astronomers have learnt that strong and ordered magnetic fields are critical to how black holes interact with the gas and matter around them. Black holes are basically gravity wells. Anything that gets too close winds up being ripped apart and consumed by the black hole. But it doesn't happen all at once. Firstly, the material is torn apart by powerful gravitational forces, forming an accretion disk around the black hole just beyond a point of no return called an event horizon. The material in this accretion disk is being further heated and ripped apart at the subatomic level, releasing huge amounts of energy in the form of X-rays. Most of this material will eventually pass beyond the event horizon, a point of no return, beyond which it falls forever towards the black hole's singularity. But a small fraction of material gets caught up in the black hole's magnetic fields, the very ones that have now been imaged. And these shoot that material out perpendicular to the event horizon, firing it deep into space, often at superluminal speeds. And these can be so bright, we see them on the other side of the universe, more than 13 billion light-years away. Now, the reason the scientists in this study used polarized light is because of some of its unique properties. You see, light is an oscillating or moving electromagnetic wave. Sometimes the light oscillates in a preferred direction. We call that polarized. You'll get the same effect when you look at a plasma screen using sunglasses which have polarization in them. Turn your head one way and the picture seems to disappear. That's because the light coming from the plasma screen is polarized. Now, you don't see the polarization without the sunglasses on because the human eyes aren't able to distinguish it from normal light. But in the plasma around these supermassive black holes, particles whirling around the magnetic field lines impart a polarization pattern which is perpendicular to the field. And this allows astronomers to see in increasingly vivid details what's actually happening in the black hole's regions, and that allows them to map their magnetic field lines. By imaging polarized light from hot glowing gas near the black hole, they're able to directly infer the structure and strength of the magnetic field lines which are threading through the flow of gas and matter that the black hole's feeding on and ejecting. Polarized light teaches science a lot about astrophysics, including the properties of gas and the mechanisms taking place as the black hole feeds. But imaging black holes in polarized light isn't as easy as simply putting on a pair of polarized sunglasses. And this has been especially true for Sagittarius A*, which is changing so fast it simply doesn't sit still for pictures. Imaging Sagittarius A* required sophisticated tools above and well beyond those previously used for capturing M87, which was a much steadier target. To observe Sagittarius A*, the authors linked 8 telescopes around the world, in the process creating a virtual Earth-sized telescope, which they've called the Event Horizon Telescope. This report from the Event Horizon Telescope collaboration.
Just over 100 years ago, Einstein showed how gravity could be imagined as a distortion of space-time. His equations revealed that an object small enough and massive enough could hide behind an event horizon, a point where gravity is so strong that not even light could escape. Astronomers now believe that these objects, known as black holes, exist. They inhabit the centers of almost all galaxies, where they can grow to be millions or billions of times the mass of our Sun. The Event Horizon Telescope, or EHT, is the first experiment designed to capture a black hole's image. In doing so, the EHT tests Einstein's theory of gravity at one of the most extreme places in the universe, the event horizon. The best chance we have of taking a picture of an event horizon is the supermassive black hole at the center of our own Milky Way. Though it is 4 million times as massive as our Sun, it is so far away that mapping its event horizon is equivalent to standing in New York and counting the individual dimples on a golf ball in Los Angeles. Gas falling towards this black hole heats up to billions of degrees, causing the event horizon to appear as a silhouette whose size and shape are predicted by Einstein's theory. It is best to observe this silhouette in light with a wavelength of about 1 millimeter, where the gas glows most brightly, and light can travel unimpeded from the center of the galaxy to telescopes on Earth. Close to the black hole, the light waves appear circular, like ripples in a pond, but by the time they reach Earth, they are essentially plane waves. Imaging a black hole at this wavelength requires a telescope as big as our planet. The EHT uses a global network of dishes to simulate a telescope of this size. Each dish collects and records radio waves coming from near the black hole. The data are then combined to create the image of the event horizon. This will only work, however, if the dishes are completely synchronized. To understand this, let's use the analogy of a mirror, such as an optical telescopes used for stargazing. Imagine the EHT formed from all the different array sites as one big parabolic mirror. The mirror is curved so that when a line of waves comes into the dish, they bounce off at specific angles and arrive at the focus at the same time. When the EHT sites are synchronized, their recordings can later be perfectly aligned in the same way that the mirror aligns the optical light. If the surface of the mirror is not stable, if it is vibrating, for example, the reflected light rays will not combine properly at the focus. For the EHT, an unstable mirror surface is analogous to an unstable recording. To ensure stability, the EHT uses atomic clocks that would lose only 1 second every 100 million years. The amount of data recorded during observations is so large that it could never be transferred over the internet. Instead, the recordings are stored on hard disks and shipped back to a central facility for processing. There, a supercomputer combines the data from all the sites, staggering them during playback to account for the time difference between waves getting to each telescope. The resulting data can then be used to make images with extreme magnifying power. As more dishes join the AHT, and the more widely spaced they are, the sharper our image of the event horizon will be. In April 2017, the AHT coordinated observations of the Milky Way's central black hole using a global network of telescopes. The results transform our understanding of black holes, gravity, and even the universe.
Because Sagittarius A star moved around while astronomers were trying to image it, it was difficult to construct even an unpolarized image. In fact, the first images were really an average of multiple images, owing to Sagittarius A star's constant movement. The authors were relieved to find out that polarized imaging was even possible. Some models were far too scrambled and turbulent to construct a polarized image. But now, having achieved that, astronomers have a sample of two supermassive black holes, with very different masses and from very different host galaxies. Since both are pointing scientists towards strong magnetic fields, it suggests that this may be a universal and perhaps fundamental feature of these kinds of systems. And one of the similarities between these two specific supermassive black holes might be a jet. But while the team have imaged a very obvious jet in M87 star, they're yet to find one in Sagittarius A star. And the Event Horizon Telescope is slated to observe Sagittarius A star again later this month. This is SpaceTime. Still to come, new studies show that blue supergiant stars can be formed through stellar mergers. And we peer into the tendrils of a distant galaxy. All that and more still to come on SpaceTime. A new study has found that some of the brightest, hottest and most luminous stars in the universe, spectral type B blue supergiants, can be created by the mergers of two less massive stars. These giants of the cosmos are at least 10,000 times more luminous and up to 5 times hotter than our Sun. And they have masses of between 16 and 40 times that of the Sun. Current astrophysics tells us that these are created during a very rapid phase of stellar evolution, and so they should be fairly rare. Yet when astronomers peer into the heavens, they see lots of them. Well, a new study reported in the astrophysical journal Letters claims that an important clue to their origin lies in the fact that most blue supergiants are actually observed as single stars. That is, they have no gravitationally bound companions. And the problem with that is, most stars in our galaxy are born in binary or multiple star systems. Our Sun is a rare exception to that rule, but that's another story. So, why are blue supergiants single? Well, the answer, according to this new study, is that massive binary stellar systems merge to produce blue supergiants. The study's lead author, Athira Menon from the Institute of Astrophysics in the Canary Islands, says the findings are based on computer model simulations combined with actual observational studies looking at 59 early spectral type B blue supergiants in the Large Magellanic Cloud, a satellite galaxy orbiting our own galaxy, the Milky Way. By simulating the mergers of evolved giant stars with their smaller stellar companions over a wide range of parameters, taking into account the interaction and mixing of the two stars during the merger, they found the newly born stars live as blue supergiants during the second longest phase of a star's life. This is after it's left the main sequence and is burning helium in its core. The authors found that the stars born from such mergers have greater success in reproducing the surface composition, especially the nitrogen and helium enhancement, of a large fraction of observed sample stars compared to conventional stellar models. And this indicates that mergers may well be the dominant way to produce blue supergiants. The findings appear to provide a significant step forward in solving an old problem of how blue supergiants form, and indicates the important role of stellar mergers in the morphology of galaxies and their stellar populations. The next part of the study will attempt to explore how these blue supergiants explode into supernovae and contribute to the black hole and neutron star landscape of the universe. This is SpaceTime. Still to come, peering into the tendrils of a distant galaxy, and Moscow sends a new crew to the International Space Station. All that and more still to come on SpaceTime. NASA's Webb Space Telescope has provided astronomers with a new view of a spectacular star-forming region called NGC 604, which is located deep inside M33, the Triangulum Galaxy. Located some 2.73 million light-years away, the Triangulum Galaxy is a spiral galaxy with a diameter of roughly 61,100 light-years. That makes it the third largest galaxy in our local galactic group, behind the Andromeda Galaxy M31 and our own galaxy, the Milky Way. The Triangulum is thought to be a satellite galaxy of Andromeda, or possibly on its rebound into M31 due to their gravitational interactions, velocities, and proximity to one another in the sky. It's also the smallest spiral galaxy in our local galactic group, although both large and small Magellanic Clouds were also once spiral galaxies before becoming distorted by their encounters with the Milky Way. The new James Webb observations of M33 have revealed the structure known as NGC 604 to be a hotbed of star formation. The formation of new stars and the chaotic environments they inhabit is one of the most well-studied but also mystery-shrouded areas of cosmic investigation. Two new Webb images using the observatory's near-infrared camera and mid-infrared instrument are showing cavernous bubbles and stretched-out filaments of gas deep inside the nebula. It's providing a far more detailed, complete tapestry of star birth than previously seen. Sheltering among NGC 604's dusty envelopes are more than 200 of the hottest, most massive stars known. These are spectral type O and B blue stars, some with masses over 100 times that of the Sun. It's actually quite rare to find such a huge concentration of these types of stars in the nearby universe. In fact, there's no similar region that we've identified within our own galaxy. So, this concentration of massive stars, combined with their relatively close distance, means NGC 604 is giving astronomers a unique opportunity to study these objects at a fascinating time early in their life cycles. Based on the new observations, NGC 604 is estimated to be about 500,000 years old, just a baby in astronomical terms. The massive cloud of glowing gases and dust is some 1,300 light-years across. Webb's also detected bright orange-coloured streaks in the near-infrared image, signifying the presence of carbon-based molecules known as polycyclic aromatic hydrocarbons. And this material plays an important role in the interstellar medium and in the formation both of stars and planets. But the origins of this molecule are still a mystery. This report from NASA TV.
NASA's James Webb Space Telescope has taken two new images of the star-forming region NGC 604, located in the Triangulum Galaxy, 2.7 million light-years away from Earth. Sheltered among these dusty envelopes of gas are more than 200 of the hottest, most massive kinds of stars, all in the early stages of their lives. The largest of these stars can have more than 100 times the mass of our own Sun. Using Webb's powerful near-infrared camera, called NIRCam, the most noticeable features are tendrils and clumps of bright red emission, extending out from areas that look like clearings or large bubbles in the nebula. Stellar winds from the brightest and hottest young stars have carved out these cavities, while ultraviolet radiation ionizes the surrounding gas. This ionized hydrogen appears as a white and blue ghostly glow. As you travel further from the immediate clearings of dust, the deeper red signifies molecular hydrogen. This cooler molecular gas may be the fuel for future generations of stars that are forming. Webb's mid-infrared instrument, called MIRI, lets us see a new window into the diverse and dynamic activity of this region. In the MIRI view of NGC 604, there are noticeably fewer stars. This is because hot stars are much fainter at these wavelengths of light, while the large clouds of cooler gas and dust glow brightly. Some of the stars seen in this image from the surrounding galaxy are red supergiants, stars with low surface temperatures that are very large, hundreds of times the diameter of our Sun. How stars are born and how they interact with their environments are two big questions in astronomy today that are actively being studied with the Webb telescope. Webb is showing us parts of the story of star formation that we could never see before, revealing more about the universe and our place in it.
And in that report from NASA TV, we heard from Webb's senior project scientist, Jane Rigby. This is Space Time. Still to come, Moscow sends a new crew to the International Space Station, and later in the science report, it's true. The music of today really isn't as good as what it was 20, 30 or even 40 years ago. I knew it. All that and more still to come on Space Time. Three new crew members have arrived aboard the International Space Station. Their Soyuz MS-25 capsule launched 2 days earlier aboard a Soyuz 21A rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The flight had been delayed by several days after mission managers detected a voltage drop in a chemical power supply just 20 seconds before the initially planned liftoff, triggering a launch abort.
Launch Pad 6, Site 31 at the Baikonur Cosmodrome in Kazakhstan, where that Soyuz 2.1A booster stands fully fueled once again, ready for launch to send an American astronaut, a Roscosmos cosmonaut, and a spaceflight participant from Belarus into orbit, this time on a 2-day journey to reach their destination, the International Space Station. The initial attempt to launch Soyuz MS-25 on Thursday was scrubbed at the T-minus 20-second mark when the automatic launch sequencer cut off the countdown. The crew was never in any danger as the Soyuz booster was safed, enabling the crew to be extracted from the Soyuz within an hour. Engineers in Baikonur determined that the cause of the scrub was a low voltage rating in the booster's first stage electrical system. Batteries were changed and retested Friday morning, setting the stage for today's launch attempt. The 3 crew members escorted to the stairs, the stairwell at the base of the Soyuz 2.1A booster. They climbed a few stairs, waved goodbye to well-wishers, and entered the elevator there for the ride to the top of the Soyuz rocket to board their spacecraft, which they've now been aboard for about 2 hours or so.
Auto sequence initiated.
Launch.
Second umbilical now retracting.
Ignition.
This initiates engine start. We now have engine ignition.
Preliminary.
Turbo pumps and engines up to flight speed, now at full throttle.
Engines to maximum thrust.
We have liftoff. Dyson, Novitsky, and Vasilevskaya finally underway on a 2-day journey to the International Space Station. And we have third stage shutdown and third stage separation.
Separation is confirmed.
The command now will be given to deploy the Soyuz solar arrays. That now underway.
MCC Moscow.
And the solar arrays and navigational antennas have all been deployed. Perfect ride to orbit for Tracy Dyson, Oleg Novitsky, and Marina Vasilevskaya. The 2-day chase to catch up to the International Space Station now underway.
The International Space Station remains one of few areas of cooperation between Moscow and the West in the wake of the Kremlin's invasion of Ukraine. Russia had previously threatened to quit the orbiting outpost, but ongoing delays in developing a new core module for their own independent Russian space station has seen the Russian Federal Space Agency Roscosmos agree to remain part of the International Space Station project until at least 2028. Meanwhile, NASA and its other partners hope to continue operating the ISS until at least 2030. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has confirmed that spending less time sitting could help reduce blood pressure in people aged over 60. The findings, reported in the Journal of the American Medical Association, looked at some 280 patients with hypertension, splitting them into 2 groups. One group was given interventions to help them reduce the time they spent sitting down, including health coaching, a standing desk, and a fitness tracker, while the second group only received health coaching. The study found that those in the sitting intervention group spent about 30 minutes less a day sitting and also had a reduction in their blood pressure of around 3.48 millimetres of mercury. The authors say that reducing the amount of time sitting could be a simple but promising approach to improve the health of older adults. A major step forward has been taken in sugarcane research with a mapping of its complete genome, which, as it turns out, is 3 times the size of the human genome. Sugarcane contributes some $2.2 billion to the Australian economy and accounts for up to 80% of global sugar supplies. The new study, reported in the journal Nature, says the mapping of its genetic blueprint opens opportunities for new tools to enhance breeding programs for this valuable food crop and bioenergy source. Well, it's true, today's music really isn't as good as what it was back in the olden days. A new study by Austrian and German researchers has found that the lyrics of English language songs have become more repetitive and simpler over the last 40 years. The research, published in the journal Scientific Reports, analysed the lyrics of some 12,000 songs across genres spanning from rap, country, pop, R&B and rock, all of which were released between 1980 and 2020. They say that while the number of different words used in songs have decreased over that period of time, the songs have tended to use longer words, but the repetition made them more simple overall. Additionally, the lyrics appear to have become more emotional over time. The use of emotionally positive and negative words increased in rap songs, whereas R&B, pop and country music songs increased their emotionally negative lyrics. Now, for the record, I have to point out that I was a radio music DJ long before I became a journalist. And so I speak with a modicum of authority when I say that you just can't beat the rock music of the 70s, the new romantics of the 80s, or the grunge of the 90s. And anyone who says otherwise must be wrong.
And now for something completely different.
We all know that astrology is not a science, and it has no scientific validation. Yet newspapers and websites continue to publish horoscopes, and people still ask each other what their star sign is in a futile hope that it'll provide some sort of clue about their personality. Tim Mendham from Australian Skeptics says the reasons behind this ongoing belief in astrology are multifaceted, encompassing elements of psychology, personality traits, societal influence, and personal preference. He says this new study, reported in the journal Personality and Individual Differences, explored the surge in astrology beliefs, finding narcissism linked to a higher belief, while intelligence showed a negative correlation.
Astrology has been around for how long? Several thousand years. Why do you believe, therefore, that these signs, which correspond to parts of the year, will influence what you do or say something about what you are? The whole philosophical concept, to me, falls apart totally. One, why a star sign at your birth should be influential on you is unknown. Why not at conception rather than at birth? Because your birth could be induced or late or whatever, premature, anything. So why should that have an influence on you? Two, how does it have an influence on you? Your listeners will know about, gravity and the inverse square law and blah, 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 all that sort of stuff. And the fact that obviously the constellations are not all in one plane, they're all over the place. They're like a 3D image, so that if you turn around from a different direction, they look totally different.
Yeah, there are 13 of them, not 12.
That's right. Some even suggest 14, actually, to being nasty. 13 at least, yes. Ophiuchus normally gets left out of the zodiac. And then, of course, the length of the time that they're important varies from the actual time that they're in the sky, because some of them are actually only around for about 7 days, and others are around for 35, high 30s, but we tend to even them out just to make life easier for the astrologers. But why do people believe in them? That's the $64 question, because obviously there's no reason to. There's no explanation for why it should be influential, whether it's even character or whether it's foretelling the future or whatever. A lot of astrologers say they no longer look at the planets, even though planets form a major part of astrological character assessment, etc., your birth chart. Some of them say they no longer look at the constellations because they know they're an artificial concept, and so you start wondering, well, what are they looking at? Some people suggested that it sounds like it's sciencey. It's an ology word, like geology and anthropology and things like that, so which we know that ology just means a study, and it's from the Greek word logos, meaning word, also learned and studying that sort of thing, so there's nothing necessarily scientific. You could be studying teddy bears if you want, teddy bearology. Astronomy doesn't have an ology to it, but that's the other thing, because it's astronomy, astrology, people think it's scientific, but that's a pretty superficial way of looking at it and of looking at people for why they believe. Some are suggesting that, like a lot of beliefs. And at other times, we've discussed belief in psychics and crystal balls and all sorts of things like that, that it provides a coping mechanism dealing with traumatic events. It's something to hang on to in an uncertain world or in a stressful world, and that's been put forward a lot of times. Most people know their star sign, which, as we know, as a sun sign, as it's called, it has no bearing whatsoever. It's totally ridiculous to say 1/12 of the population will have this future and another 12 will have a different future. Even
Well, thanks to the Milankovitch cycles, which we know are real, the star signs don't really match up with your date of birth anymore.
No, the precession of the equinox.
Yes.
Which means that the Earth, because it's on a tilt, as we know, and because there's a little vibration in that tilt, it's like a top that's leaning over and having a little shake at the same time, means that we're actually changing the positioning of the stars against the background, or the foreground, if you like, of the sun. The signs that are behind the sun at a certain time of the year are changing over a period of about 2,500 years. We change through one star sign. So it's about 25,000 years, roughly, whatever, you can take an even of that. So we'll go through the entire zodiac. Now, most star charts in the newspaper will start with, I think, Aries, which is, of course, was the spring in Babylonian times, right? For the start of a new year, a new planting year, etc. And that's the only reason why they start with Aries. It's because of the Babylonian thing when they have plants, and it's spring. But gradually, that spring is actually going into Aquarius now, not Aries, which is why this is the dawning of the age of Aquarius, for those who remember the 60s musicals. I certainly do. And that's what it means. So we're heading, and no one's exactly quite sure whether the changeover spot is. It's obviously over a period of a long time. But yeah, we're probably now in the age of Aquarius, where those newspaper columns should start with Aquarius rather than Aries, if they're really talking about starting with spring. So for those people who think they're Aquarians, they're probably not. They're probably, was a Capricornian, they were the one who's Aquarius, and so therefore you are a different star sign, so you have totally different character from what you've been told that you are. Your personality is not what you think it is. You can blame the precession of the equinox for that, which is always fun to use at a party.
For dinner parties, yes.
It is, excellent. So you said, what? The procession of who? No, precession.
Look,
yeah.
I just don't understand because I'm too stupid, that's what I'm told. And there's probably some truth in that.
There might be psychological truth in what people are trying to hang on to. The fact that astrology has no truth whatsoever, nothing, zero, seems to be irrelevant to these sort of things.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.